Hello everyone. Welcome to our channel, the Digital Institute of Computing Technology. In this presentation we will have discussion on the topic Modules and Packages in Python Programming Language. Modules and packages in Python allow you to organize your code in a logical and manageable way. First, let's see the definition of a module. What is a module? A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py added. Modules can define functions, classes, and variables, and they can also include runnable code. Example, let's create a module named mymodule.py with the following content. File name is mymodule.py, includes definition for functions. Greet and add as shown. Def greet, name, return hello name. Def add, a, b, return a plus b. Now, you can use this module in another Python file by importing it. Let's create a file named main.py with the following content, as shown. Import mymodule. Print mymodule.greet. Alice. Print mymodule.add. 3,4. This is a simple example of how you can create a module and use it in your code. Now let's see the definition of a package. What is a package? A package is a way of structuring Python's module namespace by using dotted module names. A package is a directory that contains a special file named __init__.py and can contain multiple modules. Example, let's create a package named mypackage with the directory structure as shown. It has two modules, namely module1.py and module2.py. along with __init__.py file, which makes this folder a package. Module1.py contains the definition for function named foo. Path of this module is mypackage/module1.py, and module2.py contains the definition for function named bar. Path of this module is mypackage/module2.py. The file __init__.py can be empty, but it makes the directory a package. In this case it is empty. Path of this file is mypackage/_init__.py. Now, let's use this package in another Python file, main.py. As shown, we are importing the modules module1 and module2 from mypackage package. Using the statement from mypackage import module1, module2. Now, we can access the function foo from module1 and function bar from module2. As can be seen, print module1.foo will print foo from module1. Print module2.bar will print bar from module2. Let's consider one more example where you have a package to handle various mathematical operations. Example, let's create a package named mathlib with the directory structure as shown. It has two modules, namely arithmetic.py and algebra.py, along with __init__.py file, which makes this folder a package. Arithmetic.py contains the definition for function named add and subtract. Path of this module is mathlib/arithmetic.py. Def add a comma b, return a plus b. Def subtract a comma b, return a minus b. Algebra.py contains the definition for function named solve_quadratic. Path of this module is mathlib/algebra.py. This function evaluates the roots of the quadratic equation by first evaluating k, discriminant, and finally returns roots root 1 and root 2, as shown. Also, this function is importing cmath to calculate the square root. Next, the file __init__.py is empty. Path of this file is mathlib/__init__.py. Now, let's use this package in another Python file, main.py. As shown, we are importing the modules arithmetic and algebra from mathlib package. Using the statement from mathlib import arithmetic, algebra. Now, we can access the function add and subtract from arithmetic module and function solve_quadratic from algebra module. As can be seen, perform arithmetic operations using arithmetic.add and arithmetic.subtract function. Perform algebraic operations using algebra.solve_quadratic function. So, by using modules and packages, you can keep your code organized, reusable, and maintainable, making it easier to manage large projects. Now let's consider one third-party package like requests and analyze. First of all, to use this package, you need to install it. Pip is the package installer for Python. It allows you to install and manage additional libraries and dependencies that are not included in the standard Python library. Requests is a Python library used to make HTTP requests. It simplifies the process of sending HTTP requests and handling responses. It is used for interacting with web services and API. Supports various HTTP methods like GET, POST, PUT, DELETE, etc. Handles HTTP connections, requests, and responses, making it easier to work with web data. Requests package can be installed using command pip install requests. Let's see the steps involved. When pip installs the requests package, resolving the package, pip contacts Python package index to find the latest version of the requests package. Pip uses the internet to query the Python package index for the requests package metadata. Downloading the package, pip downloads the requests package. The package is usually a wheel file or a source archive. Checking dependencies, pip checks for any dependencies required by the requests package. Dependencies for requests typically include lib3, churday, etc. Downloading dependencies, pip downloads these dependencies from Python package index if they are not already installed. Each dependency package is downloaded in a similar manner to the main requests package. Installing the package, pip installs the requests package and its dependencies to your Python environment. The installation process places the files in the site packages directory of your Python environment. Updating metadata, pip updates the metadata to include the newly installed package. The package is now available for import in your Python scripts. This is how the output might look like when you run pip install requests. The requests package, like any other Python package, has a specific structure. When you install the requests package, it comes with various modules and sub-modules that provide different functionalities. Here is a simplified view of its structure. The requests package's directory structure might look something like this. Now, let's see the role of each of these files in the requests package. __init__.py file initializes the requests package. Next, adapters.py file contains the transport adapters used by the session. Next, API.py file provides the high-level API for making requests such as get, post, put, delete, etc. Next, auth.py file implements various authentication mechanisms. Next, certs.py file contains SSL certificates. Next. Compat.py file provides compatibility functions for different Python versions. Next. Cookies.py file manages cookies and cookie jars. Next. Exceptions.py file defines the exceptions used by the requests package. Next. Help.py file provides help messages for the requests package. Next. Hooks.py file implements the hooks system for customizing request behavior. Next. Models.py file defines the core data structures like request, response. Next. Packages contains third-party libraries bundled with requests, such as erlib3, etc. Next. Sessions.py file manages session objects that hold configuration across requests. Next. Status_codes.py file provides a mapping of HTTP status codes. Next. Structures.py file implements special data structures used by the package. Next. Utils.py file contains utility functions used throughout the package. So, this is how a third-party package like requests looks. Having an understanding of its structure will help you in designing and writing your own packages efficiently and effectively. So, this covers an overview of modules and packages in Python programming language. Hope you enjoyed and liked the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.